Hello viewers, you are welcome back to Tindenius Maths and Science Tutorials. I'm very happy to see you once again. I hope you are following. We are still treating differentiation. By this time around, we are going to talk about inverse trigonometry functions. We are going to learn how to differentiate inverse trigonometry functions. So if I differentiate sine inverse, what will I get? Cos inverse, what will I get? When I differentiate tan inverse, what will I get? That is the business for today. If you are new here, kindly share, like, subscribe, and comment as well for more interesting videos. So if I have a function of, say, y equals sine inverse of x, when I find the derivative of y with respect to x, I'll get dy dx, which is equal to 1 over the square root of the expression 1 minus x squared. Why are we saying that? So today we are going to learn the proof of that. Now when we talk about inverse trigonometry function, inverse simply means the reciprocal of something. So the reciprocal of something. For example, when I have, or if I have sine, let's say sine, I have cos, and I have tan. So the inverse of sine becomes sine inverse, and the inverse of cos becomes cos inverse. Similarly, the inverse of tan becomes tan what inverse. So if I have x here, so I'll get x over here, x over here, as simple as that. So that's why I have y is equal to sine inverse of x. When you find the derivative, or when you differentiate y with respect to x, this is what you should be getting. Okay. Now, before I proceed, we have to understand some basic concepts. So in trigonometry, we have an identity called the Pythagorean identity, or the Pythagorean identities. So what is the Pythagorean identity saying? So one of the identities is when we have sine square theta being added to cos square theta, it gives 1. Here can be theta, x, y, phi, pi, epsilon, epsilon naught, omega, omega naught. It all depends on you. So this one is the same as me writing sine squared x plus cos squared x is equal to 1. Similarly, sine squared y plus cos squared y is equal to 1. Since it is an identity, it will hold. Alright. Again, when I divide sine over cos, I will get tan. So let's say if I have sine squared y plus my cos squared y, which is equal to 1. Dividing through by cos, so we are dividing here by cos squared y, here to by cos squared y, here to by cos squared y. I will have sine over cos gives tan. So if I have sine x over cos x, I'll get tan what? X. So if I have sine over cos, I'll get tan over here. I have square here, so I'll get my square here, then y. Then plus this cancels this 1, which is equal to, again, when I have 1 over cos, it gives me sec. So if I have 1 over cos x, I'll get sec x, as simple as that. So similarly, I have 1 over cos, so I'll get what? My sec. I have squared here, so I'll write square, then I'll write what? Y. This is another identity. So I have this, and I have what? That. Again, when you have, let's say, cos squared x, This is the same as cos x all squared. Similarly, tan to the power 3. This is the same as tan raised to the power 3x is the same as tan x all cubed in that sense. Okay, and the last thing you should note also is when you have a function of say f, so a function and its inverse this way. So a function of its inverse this way, it gives x. So a function and its inverse gives you x. So when I have cos multiplying cos inverse of, let's say, x. Since it's cos and its inverse, I'll have what? My x. When I have sine and its inverse, again, so let's say here's y, again I'll get what? I'll get my y. Viewers, take note of this before I start doing the proving. Alright? Okay, so let's start the business now. So we have y equals sine inverse. When I find the derivative of y with respect to x, I'll have dy dx is equal to 1 over the square root of the expression 1 minus x squared. So let's look at the proof over here. Proof. So given that y equals sine inverse of x. So y is equal to my sine inverse of x. So if I want to clear the sine inverse, I'll just take sine of both sides. So if I take sine of both sides, I'll have sine y over here, which is equal to the sine here and its inverse this way, and you will get what? Sine y is equal to what? Is equal to x. So remember, sine and its inverse gives what? X. Is that not so? Good. So having gotten sine y is equal to my x over here, when you have a situation whereby you are going to differentiate two variables at the same time, we call it implicit differentiation. So I can see y here, I can see x here. I'll have to differentiate them. So I'll just employ the implicit differentiation procedure. And one thing about implicit differentiation is that whenever you are differentiating a term containing y, after differentiating add dy dx. What do I mean by this? So let's say if I have y raised to the power 3. So using the power rule, when I differentiate this, I'll have what? I'll have 3y what? Squared. Because I'm differentiating a term containing y, I will add what? Dy over what? Dx. That is the rule of implicit differentiation. After you have done this, then you make dy dx the subject, and that is all. So here, when I differentiate sine, I will have cos y. So if I differentiate sine y, I'll get cos y. Viewers, we've done trigonometry differentiation. So if this is your first time, you can kindly visit the previous lectures, and they are all over there. So I'll get sine y. Because I'm differentiating a term containing y, I'll add what? My dy over dx because of the presence of the term y. which is equal to, when I differentiate x, I'll get 1. Alright, so I'll make dy dx the subject. So I'll divide both sides by cos y over here, cos y, then I'll divide here by cos y. So cos y cancels cos y. I'll have what? Dy over dx is equal to 1 over cos what? Y. When you come here, you realize when I was trying to write the dy dx, I had 1 over the expression, 1 over the square root of the expression, 1 minus x squared. What does it imply? It implies that we are trying to work in terms of x. We are working in terms of x over here, and we are not working in terms of y over here. But we know from trigonometry that, employing the Pythagorean identity, we said sine squared y plus cos squared y gives us what? 1. So because the denominator here is cos y, I will make cos y the subject from here, this. So let me just do that. I have cos squared y is equal to, I have my 1, then minus sine squared y. I want to make cos y the subject, not cos squared y. So we already know that from the introduction. We said cos squared y is the same as cos what? Y all squared, which is equal to what? 1 minus sine squared y. Then I'll just take the square root of both sides this way. Then I'll have cos y is equal to square root of the expression 1 minus sine squared y. You are still, you have to work in terms of x. So gradually, x will appear over there. So we are just going step by step. Then I have here, so we said dy over dx is equal to 1 over cos what? Y. And y, dy over dx is equal to 1 over, we just wrote the expression for cos y over here. We said cos y is equal to what? This expression, right? So over 1 minus sine squared y. Again, coming here, we are working in terms of x. But what we've had over here is trigonometry, a trig function. So we have to work in terms of x. So how do we do that? Again, recalling this. So recall that from here, we said, from here, where we had to apply the principles of implicit differentiation, we said sine y is equal to what? Is equal to x. So if I'm saying sine y is equal to x, and I'm trying to square both sides, this is the same as, let's say, sine y all what? Squared, which is equal to then x what? Squared. That is if I want to square both sides. So I'll have sine squared y is equal to what? My x squared. So we just want to work in terms of x. So we need to manipulate this to get x somewhere. But you realize when I square both sides, I'll have this. So sine squared y in terms of x is what? Is x squared from here. So I'll substitute this into this to get my final answer. So I'll have dy over dx is equal to 1 over the square root of the expression 1 minus, now here I'm saying sine squared y, but when you come here in terms of x, we said the sine squared y is equal to what? X what? Squared. So I have my x squared. Viewers, this is how the proving is done, as simple as that. So when I meet you next time, we are going to also learn how to prove the inverse, or we are going to prove the cos inverse of x. So when I have y is equal to cos inverse of x, what will I get? So please, for the cos inverse, it's just simple. So we have cos inverse of x When I find y over the x, I'll have negative 1 over the expression square root of 1 minus x squared. I'll do this in my next lectures. See you there. Subscribe.